Hello students, welcome back. Now today in this video we will discuss about the total internal reflection of light. So let's start. For understanding the today's concept, you should know what you mean by the reflection of light. When you take the mirror, on the reflecting surface, when the ray is incident, suppose this is our point of incidence, suppose I am considering it as O, a line perpendicular at this point of incidence is known as the normal. After striking the surface, the ray reflect back. So this is reflected ray and this is incident ray. Now angle between the incident ray and the normal is known as angle of incidence. And angle between reflected ray and the normal is known as angle of reflection. Now according to the laws of the reflection of light, what we have done, this incident ray, reflected ray, normal lie in the same plane, and this incident ray, reflected ray, they are in the same medium, both the side the same medium only is there. Now, so angle of incidence is equal to angle of reflection. If I say this is 60 degree, then this side also it is 60 degree. This concept of reflection of light you have to keep in mind. Now students, in the reflection of light, what you have done, that both the incident ray and reflected ray, they are in the same medium. So the speed of the light remain the same. That's why both form same angle with the normal. That's why angle of incidence and angle of reflection both are equal. But when light travel from one medium to another medium, then we have to consider the density of the medium. If among a pair of media, one will have the less density, another will have the more density. So less denser one, that medium is known as the rarer medium, while the one which has more density, that is a denser one. So that medium we consider as a denser one. Now when light travel from rarer medium to denser, here I have taken air as a rarer medium and glass as a denser medium. So as the ray travel from air to glass, the speed will decrease because now the second in the pair, the second medium is denser. Because of that, it will deviate. It is the normal path. So it will deviate from its normal path and bends towards the normal. And now this is our angle of incidence. This is our angle of refraction. So, when light travel from one medium to another medium, due to change in its speed, the ray deviates from its normal path. That is known as refraction of light. Now, here I have taken denser first and rarer as the second medium. Now, this is our angle of incidence. And this is our angle of refraction. Now here, angle of refraction is less than the angle of incidence. Here, angle of refraction is more than the angle of incidence. Why? Now, when light travels from rarer medium to denser medium, the speed decreases. Because of that, this refracted ray moves towards the normal. Understood? That's why the incident angle will be always greater than the angle of refraction. Now, in the reverse way, when the light travels from denser to rarer medium, the speed of the light in the second medium increases. Because of that, this refracted ray moves away from this normal. That's why the angle of refraction will be more than the angle of incidence. In the third case, student, see incident ray and the normal I have drawn the same one. It means our angle of incidence is 0. Incident ray itself is perpendicular to this interference of both the media. So, because of this, there is no deviation. Your refracted ray also moves as. So ray remain undeviated when angle of incidence is 0 or incident ray is perpendicular at the interface. Now students, I have taken denser medium here and rarer medium here. Then I have taken 1, 2, 3, 4, 5 incident rays. AO, which is perpendicular to the interface. Then I have taken AP, AQ, AR, AS. Okay. Now, you know the concept that when light travels from denser to the rarer medium, refracted ray move away from the normal. Now, AO is an incident ray which is perpendicular at the interface of the both the medium. It means angle of incidence is 0 and we have done the ray will remain undeviated. Okay. Now, angles 0 to 90 degree. In between we have to consider for the angle of incidence. For first one, this is our angle of incidence. Let's see what happens. Now, at point P, this is our refracted ray. Now, part of it, see, I have shown with the green color. Part of it is reflecting back, that is in the same medium. So, this one is an angle of refraction. Suppose I consider it as an R1. So, this is our angle of refraction. Now, refracted move away from the normal as light travel from denser to rarer medium. Now, at this incident, part of it is reflecting back. So, we say that there is a partial refraction of light and partial reflection of light. Now, when you just see this incident angle, suppose this is my I1, this I am considering I2. Now, angle has increased. I2 is greater than I1. Then what happened? Now, at point Q, again a part of it is reflecting back. Now, this angle of refraction has increased. So, as the angle of incidence increases, angle of refraction also increases. So, still this refracted ray move away from the normal. It is bending towards the interface. Now, at this case also, partial reflection and partial refraction is there. But at point P, refraction is strong, reflection part is weak. But as the angle of incidence is increasing, refraction part will become weaker and the reflection part becomes stronger. Now at point R, my angle of incidence still greater than the previous one. It means I3 is greater than I2. Now at this point of incidence, what happens? Let's see. Now, part of it is reflecting back and refracted ray lie on the interference of the both, means this angle is 90 degree. So, I3 is 90 degree. Okay. Now, so this angle of incidence is in denser medium. Angle of refraction, which is 90 degree, it is in the rarer medium. Again at point R, partial reflection of light is there, partial refraction of light is there. But only the difference is that as we move, as the angle of incidence is increased, angle of refraction is also increasing. At point R, it has become 90 degree. This angle of incidence, where corresponding angle of refraction is 90 degree in the rarer medium, is known as critical angle. And we indicate it as IC. So what is your critical angle? Critical angle is nothing but the angle of incidence in the denser medium corresponding to which angle of refraction in the rarer medium is 90 degree. Now at this stand, that suppose my angle of incidence is I4 which is greater than I3. It means my I4 is greater than I3. I3 is our critical angle. It means now my angle of incidence is greater than critical angle. So at point C, my angle of incidence is greater than critical angle. At this instant, whole ray is reflecting back in the same medium. See, my incident ray is also in the denser medium. My reflected ray is also in the denser medium. It means totally ray has reflected. This is known as total internal reflection of light. So when it takes place, when our angle of incidence is greater than critical angle and light travel from denser to rarer medium. So two conditions you have to keep in mind. When does it occur? When angle of incidence is greater than critical angle and light travel from denser to rarer medium. Then only there is total internal reflection of light without using any mirror. Students, thanks for watching this video. Hope you have understood the concept. Then also if you have any doubt, comment or mail. Students, don't forget to like, share and subscribe. Thank you.